Sine, cosine, and tangent notes. Right triangles have properties which allow a person to use formulas to find missing sides and angles in these triangles. We have already learned about the Pythagorean theorem, a squared plus b squared equals c squared. Today we're going to talk about sine, cosine, and tangent. Sine stands for the opposite side of a triangle divided by the hypotenuse. The cosine in a right triangle stands for the adjacent side divided by the hypotenuse. And the tangent of a right triangle stands for the opposite side divided by the adjacent side. So using these three functions, we can find missing sides and missing angles in right triangles. There's a famous saying to help you remember the different combinations. So, ka, toa. And many times students will just simply write this at the top of their paper when they start a homework assignment because it makes it easy to remember. So stands for sine is the opposite over the hypotenuse. Sine, opposite, hypotenuse. Ka stands for cosine is adjacent over hypotenuse. Cosine, adjacent, hypotenuse. And toa stands for tangent, opposite, adjacent. So tan, opposite, adjacent. As long as you know those three, you can find your answers. Here's a right triangle. All right triangles are labeled in this way, where capital C represents the 90-degree angle. Capital A and capital B stand for the other two angles of the triangle. So capital letters stand for angles. Lowercase letters, A, B, C, stand for sides. And you'll notice that the letters are always across from one another. So capital C is directly across from lowercase c. Capital A is directly across from lowercase a. And capital B is directly across from lowercase b. C is always the 90-degree angle, and lowercase c is always the hypotenuse. So many times when we look at these kind of problems, we talk about what's happening from one angle. So in this problem, let's look at angle A. The opposite side from angle A would be lowercase a. The adjacent side to angle A would be lowercase b. Adjacent is another word for next to. So the side that's next to angle A or adjacent to it is b. Hypotenuse, of course, is always c. So the opposite and adjacent sides always have to be one of these two, A or B, because C is always called the hypotenuse. We can do the same thing concentrating on angle B. The opposite side of angle B would be lowercase b. The adjacent or next to side of angle B is A. And the hypotenuse, of course, is always C. So C can never be the opposite or adjacent side. C is always the hypotenuse. So A or B have to be opposite or adjacent. So how this works is I could ask you, what is the sine of A? Well, sine is so, from our little remembering statement. Sine is opposite over hypotenuse. So from A, the opposite side is A, and the hypotenuse is C. So the sine of A is A over C. Opposite, hypotenuse. Opposite, hypotenuse. The cosine of A, well, that goes with ka. Cosine, adjacent, hypotenuse. So the adjacent side to A would be B. And of course, the hypotenuse is always C. For tangent, that's TOA, opposite over adjacent. So the tangent of A would be the opposite side A over the adjacent or next to side B. Opposite over adjacent. C is not involved with tangent because C is the hypotenuse, and the hypotenuse is not part of tangent. So here's an example problem of what you would have to do. Now again, I would write SO, CA, TOA at the top of my paper. So it says, use the picture above, find the following values. So here's my right triangle, A, B, and C, and then this would be lowercase b, this would be lowercase a, and of course the hypotenuse is lowercase c. So I'm asking first for the sine of A. So imagine yourself standing on the A angle. Sine is opposite over hypotenuse, so the opposite side would be 3, and the hypotenuse would be 5. So the sine of A equals 3/5, opposite over hypotenuse. Cosine of A is adjacent over hypotenuse. So from A, the adjacent side is 4, and of course the hypotenuse is always 5 in this case. For tangent of A, that is opposite over adjacent. The opposite side of A is 3, and the adjacent or next to side is 4. For sine of B, now I'm standing on angle B. Sine is opposite over hypotenuse, so the opposite side of B is 4, and the hypotenuse is 5. Cosine of B stands for adjacent over hypotenuse. So the adjacent side from B is 3, the hypotenuse is 5. For tangent of B, I want opposite and adjacent. Opposite is 4, adjacent is 3. So notice, A and B are opposite and adjacent, depending on which angle you want. From A, 4 is adjacent. But if you're on B, then 3 is adjacent. One more example. The sine of A is opposite over hypotenuse, 24 over 25. Tangent of A is opposite over adjacent, 24 over 7. Cosine of B is adjacent over hypotenuse, adjacent over hypotenuse. And tangent of B is opposite over adjacent, 7 over 24. Just remember, SO, CA, TOA.